Welcome to the Explainer. Today we are diving into the invisible powers that basically run the show on planet Earth and everywhere else. Forces. They're the reason massive bridges stay up, and they're also the reason you can just pick up your phone. So let's get right into it.
Okay, so take a look at this bridge. Really look at it. What invisible power is holding all that steel together and keeping it from plunging into the water? But it's not just about huge things like this. What about something as simple as opening a door, or even just your body staying in one piece? Every single one of these moments is controlled by the exact same fundamental principle.
And here's the secret. It all comes down to pushes and pulls. That's it. Every interaction in the universe, from a planet orbiting the sun to the wind on your face, can be broken down into this simple, intuitive idea. This is our starting point for understanding, well, pretty much everything.
But, pushes and pulls is a great start, but we need to get a little more specific, right? What does a physicist actually mean when they use the word force? To really get it, we first need to see where it fits into the bigger picture of how things move around. So in physics, when we talk about motion, there are really two ways to look at it. First, there's kinematics. That's the how. It just describes motion, how fast something is going, what direction, that kind of stuff. But dynamics? That's where things get really interesting. Dynamics is all about the why. Why did that object start moving in the first place? That is the world of forces, and that's exactly where we're going.
All right, so here it is, the official definition. A force is a push or a pull. But, and this is super important, it has two key parts: a magnitude, which is just its strength, and a specific direction. You absolutely cannot have one without the other. This combination of strength and direction is what physicists call a vector, and it's the key to figuring out what happens when a bunch of different forces are all acting at once.
Okay, so if forces are just these invisible pushes and pulls, how on earth do scientists even study them? You can't just look at them, right? Well, it turns out they came up with this super clever and surprisingly simple tool to actually visualize these unseen interactions.
So let's picture this scenario. You've got two ice skaters pushing a third one. One is pushing from the side, and the other is pushing from behind. So the big question is, where's that third skater going to end up, and how fast will they get there? To figure that out, we need a really clear way to map out all these different pushes.
The real challenge is, how do you take all that pushing and pulling and put it onto paper in a way that actually makes sense? We need some way to just focus on our one object, the skater, and see only the forces that the outside world is putting on it.
And the solution is this really elegant four-step process. First, you take the object, our skater, and you just simplify it down to a single dot. Easy enough. Next, you draw arrows or vectors coming out from that dot for every single force acting on it. Now, this next part is crucial. You only draw the forces being applied to the object. You ignore any forces the object itself is creating. And finally, you can break down all those arrows to see what the final overall result is.
And this simple little sketch? It has a name, and it's a big one in physics. It's called a free body diagram. And don't let this simple drawing fool you. This is one of the most useful and powerful tools a physicist has for figuring out why things move the way they do. All right, so we know what a force is, and we've got a way to draw it out. The next step is to start sorting them. And what's really wild is that pretty much every single force you can possibly imagine fits neatly into one of just two big buckets.
On one side, you've got contact forces, and on the other, you've got field forces. The difference is actually really straightforward. Contact forces, as the name suggests, happen when objects physically touch each other. But field forces, that's where things get a little mysterious. They work across empty space. It's true action at a distance.
Contact forces are literally all around you, all the time. Think about it right now. The chair you're sitting on, that's a contact force pushing up on you, keeping you from falling through the floor. Your feet on the ground, your arms on a table, even tape sticking to paper. It's all just atoms getting right up close and personal.
And then you have the field forces. Gravity's the big one, right? The Earth is pulling you down this very second, even though its center is thousands of kilometers away. That pull is what we call your weight. Other great examples are magnetism or the static electricity that makes a balloon stick to the wall. No touching required.
Okay, so we've got our definition, we've got a way to draw forces, and we have our two main categories. But there's a missing piece, isn't there? How do we actually measure a force? Put a number on it. For that, we have to talk about an absolute legend of science.
You know the name, Isaac Newton.
Way back in 1687, he published his laws of motion. And in doing so, he pretty much invented the entire field of dynamics as we know it today. He didn't just describe how the world worked, he gave us the math to actually predict it.
And so, of course, the standard unit we use to measure force is named right after him, the Newton, which we shorten to a capital N. Now, the technical definition is the amount of force needed to make a 1 kilogram object speed up by 1 meter per second every second. I know what you're thinking, that's kind of a mouthful, right?
So let's bring it back to reality. What does 1 Newton of force actually feel like? It's hard to get a sense of it just by looking at the number and that complicated definition. But thankfully, there is a wonderfully simple way to picture it.
And you're going to love this. Just picture yourself holding a small apple in the palm of your hand. The force you feel from its weight pushing down on your hand, that's it. That's about 1 Newton. It's a perfect little analogy that connects this big, abstract scientific unit to a feeling we all know.
So there you have it. From the mind-boggling forces holding a massive bridge together, all the way down to the tiny little pull of an apple resting in your hand, this invisible web of pushes and pulls is everywhere, doing everything. Now that you know what to look for, the only question left is, what's the next invisible force that you're going to notice shaping the world around you?